What's up, y'all? In this video, we're going to learn how to solve quadratic equations using square roots. So let's go ahead and get started. Now, in order for you to be successful with this, we have to use a very important property in algebra, and it's called the square root property. So what does the square root property say? It basically says that when you take the square root of a number, like let's say square root of 4, you're actually going to get two answers off of this. Now, if you put square root of 4 into your calculator, whether it be on your phone, or maybe you own a calculator, or if you put it on Google, you're going to get just a positive 2 as your answer. But what the square root property says is that you actually end up with two answers. One's going to be a positive 2, and the other one's going to be a negative of that same answer. But now, why are we getting two answers instead of one? Like, where is that second answer even coming from? And why are we even thinking about it? Or why should we even think about it? Here's why you should think about it, and here's why it comes about. Remember what a square root is trying to remember the question that a square root is trying to answer. A square root is basically trying to answer what number do you multiply with itself so that you get the number under the radical. So in this case, whenever you multiply 2 times 2, you do get a positive result, a result of positive 4. But sometimes what we don't think about is that you can get the exact same result if you multiply negative 2 with negative 2, because when you multiply two negatives, you actually end up with a positive. So negative 2 times negative 2 also ends up with a positive 4. So we're not just creating another answer. It's not just coming out of nowhere. It's part of the property. It's part of the algebra and the math that we're doing here. So how is this going to help us whenever we're solving an equation? Basically, what we're going to do is that we're going to reapply the idea of equality. Our main strategy is going to be to try to isolate the squared part of our equation and then try to perform a square root on both sides of the equation. What's going to happen is that opposites will cancel each other out, and all that's going to be left with is just a numerical answer. But let's go ahead and see some examples to see this property in action. So look at this first example here. The x squared equals 49. A pretty simple example. So how do we get started? The idea is that you want to go ahead and try to isolate the squared part. Now, what do I mean by that? Basically, you have to look at your entire equation and basically make sure to check to see if that x squared, or whatever that variable squared is completely by itself. Now, in this case, the x squared is completely by itself. So what we can do here is we can just take the square root. Now, if I take the square root of one side of my equation, you have to remember equality. It's an equation. What I do on one side, I have to do on the other. So if I take the square root on this side, I also have to take the square root on the other side of my equation. So what happens? A couple of really important things happen. First things first, whenever you take the square root of a number that's squared or a variable that's squared, it's like opposites are colliding. So they cancel each other out. Just like when you would add a positive and a negative number of the same quantity. So in this case, the squared and the square root simplify out, and all that's left with is just the variable x. Now, all you have to think about is, well, what's the square root of 49? Now, what tends to happen is that we'll get the first answer of 7. But we have to remember what the square root property says. Whenever you take the square root of a number, you have to consider that it's also going to create or write down the negative version of that answer. So that means that if I take the square root of 49 and I get 7, then my other answer should be negative 7, because 7 times 7 is 49, and negative 7 times negative 7 is also positive 49. So keep that in mind whenever you are taking the square root to simplify your answer. Always consider the positive and the negative. Now let's look at this next example. We have x squared minus 5 equals 20. In this case, the x squared portion is not isolated. It's not completely by itself because there's a minus 5 there. So what do? Well, we have to perform some algebra in order to completely keep this x squared by itself. But how do we do that? Well, let's start by adding 5 on both sides of my equation. By doing so, this cancels out, so we're left with x squared equals 25, and now that x squared is completely by itself, Now we can take the square root of both sides. So square root, square root. The square root and the squared cancel each other out, so this simplifies. So x equals square root of 25. Whether you know this mentally or whether you're using a calculator, you will get a positive 5, but we must also consider that x is also going to be equal to negative 5, using the square root property. So notice that we're always getting two answers out of these problems every time. So keep that in mind whenever you're doing a question that requires the square root. You should be seeing two answers on your paper, and if you're seeing anything but that, you should definitely double check and think about to see if you're missing an answer. Let's go ahead and keep going. Same kind of question. We have x squared plus 10 equals 110. X squared is not completely by itself, so let's go ahead and fix that. We can fix that by subtracting 10 on both sides. That's leaving us with x squared equals 100. And now to solve this problem, again what we're going to do is take the square root of both sides. This simplifies out. We have x equals square root of 100 is going to be positive 10. And we also have to consider that x can also be equal to negative 10. There's a pattern here. We're always getting two answers, one positive, one negative. Let's go ahead and keep going. This time we have 2x squared equals 32. Now notice that in this case, we're not really adding or subtracting a number. But in this case, the 2 is together with an x squared, which means that they're being multiplied. So again, we have to think about the correct inverse operation. So if this is 2x squared, in order to simplify this or to isolate the x squared, let's go ahead and start by dividing both sides by 2. So then here, that cancels out, or that simplifies out. And all that's left with is just x squared. And on the other side, we have 32 divided by 2, which is just 16. Now that x squared is completely by itself, now we can go ahead and take the square root of both sides. So square root and square root, this simplifies out. We have x equals, square root of 16 is going to be positive 4, and x is also going to be equal to negative 4. I hope you're seeing a pattern here. The whole idea, the whole strategy, the whole big plan is that we're trying to keep x squared by itself first before we perform any kind of square roots. Now, what's the worst thing that could happen if you decide to take the square root before you simplify? Well, if you try to do that early on, you might end up getting a decimal answer if you put that into the calculator. So to avoid that mistake early on, let's see if we can simplify before we apply the square root. Let's go ahead and see what other examples we have here. We have 2x squared minus 5 equals 13. So now notice that there are two things currently bothering x squared. There's being a multiplication of 2, and there's also a subtraction of 5. So what we're going to do is use our inverse operations to isolate or get that x squared completely by itself. So always prioritize your addition slash subtraction first. So here we're going to start by adding 5 to both sides. Here we're going to have 2x squared equals 18. Again, because I added 5 on both sides. Now from here what we can do is that we can divide both sides by 2 so we can simplify out this 2 that's being multiplied. If we do that, then we're left with x squared. And on the other side, we have 18 divided by 2, which is just 9. All we have to do from here is just take the square root of both sides one more time, and we're left with x is equal to 3, and x is equal to negative 3. Let's go ahead and see one more example in action, just to get this idea home. 3x squared plus 5 equals 17. So again, let's prioritize the addition that we see in this problem. So what we're going to do is we're going to subtract 5 on both sides. By doing so, we're left with 3x squared is equal to 12. Now from here, we're going to divide both sides by 3 in order to simplify out the 3. And by doing so, we're leaving x squared by itself. That's why we're dividing by 3. The whole point is that we're trying to keep x squared by itself. Now from here, we have 12 divided by 3, which is just 4. And all we have to do now is take the square root of both sides. So now we're left with x is equal to square root of 4 is going to be positive 2, and we also have to consider negative 2. So here is both of our answers. So what's the big idea? The big idea is we want to try to keep the squared part completely by itself by any means necessary before we perform the square root. So if that means that if we have to subtract or add something, let's go ahead and do that first. And if there's anything we have to divide after, let's go ahead and do that next. And then if x squared is completely by itself, then we apply the square root, and we have to keep in mind the square root property, a positive and a negative. There will be a follow-up video to this that's going to cover more examples, so please be on the lookout for that. But I hope you guys learned something new today. If you liked the video, subscribe to my channel for more Algebra 1 learning videos. If you have any questions, leave them in the comments below. And just like always, please take care, and I'll see you guys next time.